Okay, here, let's start with our uniform acceleration notes. I know we took some notes last week. Those were off the PowerPoint, and it was easier for me to do some graphing. We'll acknowledge those here. But this is our first formula for uniform acceleration, and this is going to be a big one, so that you know how to do worksheet number 2 today. All right, so uniform acceleration, this is going to be objects are either speeding up or slowing down in a uniform rate. All right, so the acceleration is going to be the constant here. Okay, so with acceleration, I'm going to move my face here so you can see our stuff a little better. Okay, so what is acceleration? All right, it's a term that we use a lot, but it's one that maybe we haven't necessarily defined in our lives. It is a vector quantity, meaning that it has a direction, it has a positive and negative, that kind of thing. It's different than a scalar quantity. And it's the rate at which an object changes its velocity. All right, so it could be, we always talk about speeding up and slowing down. However, it could also be changing direction, because remember, velocity is a direction there. So acceleration is the change in velocity. And I should point out, acceleration is what you feel. All right. It's going to result in a force as you're going. So uniform velocity, you don't feel how fast you're going, you feel acceleration. You can be driving 90 miles an hour down the interstate. You can barely feel that, but the minute you slam on the brakes, that's where you feel what's coming on. So yeah, change speed, change in direction. We did the graphing before. Uniform acceleration equations. This is what we're getting to today. This is the only one you're going to need for today's assignment. Here is our equation. V sub f equals at plus v sub 0. Okay, what does that mean? V sub f, that is the final velocity. So the final speed an object or a person is going, equals a is acceleration. All right, so it's an acceleration value. T is time. And v sub 0 is whatever the initial speed was at. Now, almost all of our problems are going to be either starting or ending at a speed of 0. Okay, so that's going to help keep things a little bit cleaner for us there. So whenever you don't have that initial speed or the final speed, and it says come to a stop or starting from rest, then we're putting in the 0 for that. Other than that, this one should be very straightforward. Like I said, you're going to plug in what you know for acceleration, time, initial velocity, and solve for the unknown variable. I will say with these problems, it's probably a good idea to start off by labeling what information you have. So you'll see a question. Actually, let me pull up a question here. Okay, give me 1 second. Okay, here, share my screen. This one. Okay, so here's the worksheet. Okay, we're gonna do the first one together. It says Haley is currently stopped at her in her car at a stop sign. She speeds from rest to 30 meters per second in 5 seconds. So that equation once again is v final velocity going to equal acceleration times time plus whatever that initial velocity is. I'm not messing around with subscripts right now. Final velocity, so she speeds up from rest to 30 meters per second. So 30 is our final velocity. We are searching for her acceleration, so we don't know that. We know that she takes her 5 seconds, and we know that she's currently stopped, so her initial velocity is 0. Okay, so pretty straightforward one here. 30 divided by 5, we know her acceleration is going to equal 6 meters per second per second. Okay, so there's question number 1. That's how we handle our first our first acceleration formula there. So good luck with that. Answer keys will be coming out tomorrow.